Hey there, Year 11s. I'm going to be doing example 8 and example 9 together in this video here. So we are now trying to evaluate again using your index laws to find out values. And the better you are with your index laws, the easier it is to do these questions. So here we want to evaluate without using a calculator what negative 64 to the power of a third is. So I would change this and I would say, well, negative 64, I know that that is the same thing as writing negative 4 all cubed. Okay, now some of you might be like, well, how did I know it was negative 4 cubed? Well, first thing is 64, I wrote that as a, I'm just going to write it down here. 64 can be broken up into 8 times 8, and then 8 here can be broken up to 4 times 2, and this is again 2 times 4 is 8 as well, but notice that 2 times 2 is another 4, so I know that 4 times 4 times 4 is going to give me 64. But I also know that if I had negative 4 times negative 4, that will give me positive 16, and then if I times it by negative 4 again, that will now give me negative 64. That's why negative 64 is the same thing as saying negative 4 cubed, because you're multiplying negative 4 3 times itself. Okay, so that's where the idea is coming from. So let's rub all this out and go back. So I now know negative 64 can be written as negative 4 cubed, and all of that to the power of a third. Now we know that in our rules we can multiply the powers together here. So you can write it as negative 4 to the power of 3 times a third, and conveniently 3 times a third is 1. So the answer is negative 4 to the power of 1, which is negative 4. Then going on to B, following the same idea, we've got 9 to the power of negative half. Notice I'm using brackets to isolate it, and I'm going to do the same thing. Break the 9 into 3 squared, all to the power of negative half. And again, we know that we can multiply the powers together, and this now gives me 3 to the power of 2 times negative half, which conveniently cancels out to be negative 1. And using our negative index law, we know this is the same thing as writing 1 over 3 to the power of 1, which is 1/3. Then we have a look at C. Let's have a look at C over here. We've got 16 to the power of 5 over 2. Okay, so 16 to the power of 5 on 2. And remember, I'm going to use brackets to isolate it. I can write 16 as 4 squared. Okay, so 4 squared, or 2 to the power of 4. The reason why I did 4 squared is because I noticed the denominator is 2. And so if I can keep it in squares, what's going to happen here is we know that 4 squared is 16, and it's all to the power of 5 on 2. Now remember, you can multiply the powers when it's in this form. You got brackets and powers there, so it's 4 to the power of 2 times 5 over 2, and you can see why I wanted the 2's, because 2 divided by 2 is 1, and this now cancels out to be 4 to the power of 5. And I don't know what 4 to the power of 5 is actually. Did it want me to evaluate? It did. Oh. Well, if we were to do it by hand, we already know 4 cubed is 64, so 64 times 4, what's that? 4 times 4 is 16, carry the 1, 4 times, so 256, and you times 4 again, that's what? 4 times 6 is 24, 20, 22, 8, so 1024. Okay, that's not ideal. Usually they should give you a number that you already should know, up to cubes, not up to 5s, but this is a textbook. Here we go, D. We've now got 64 to the power of negative 2/3. And again, same thing. I need something with the 3 in the denominator. That's the hint. So I'm going to change it to 4 cubed. So 4 cubed is 64 to the power of negative 2/3. And the same thing again. You can write it as 3 times negative 2/3, and those 3's will cancel out, and you end up with 4 to the power of negative 2, which is the same thing as saying 1 over 4 squared, and that is 1 on 16. Okay, so there you go. That's example 8. And then if we go over to example 9 over here, same concept. If I go to A, and we got 3 to the power of a quarter, in our example here, we're going to change all the square roots into index powers. So this is 6 to the power of half. If you didn't know, square root is to the power of half. times, this is the fourth root, so that's 2 to the power of a quarter, so fourth root is a quarter, and then divided by, again, this is 16 3/4 already. So in this example here, it looks like we may need to find a common base, which they all do not have a common base at the moment. So what I'm going to do is I'm going to break each and every one of these into their prime factors. Okay, now 3 and 2 are already in their prime factors, just 6 and 16 they aren't. So I've got 3 to the power of a quarter times, now 6 can be written as 3 times 2, all to the power of half. Multiplied to 2 is already a prime factor, so we keep it as 2. All over 16 can be broken up into 2 to the power of 4, all to the power of 3/4. Okay, so if you do it this way, you can see now I've only got bases 3 and bases 2. So 3 to the quarter times, and remember you can expand by multiplying the powers, here. So this now gives me 3 to the power of half times 2 to the power of half times 2 to the power of a quarter, all over 2 to the power of 4 times 3/4. And we can see it simplifies very nicely here. We now get 3 to the power of a quarter plus half. So when you multiply with the same bases, you add the powers, multiply 2 to the power of half plus a quarter over here, and all over, and we can see that 4 divided by 4 cancels out, so you end up with 2 cubed. Okay, so here we go. I'm just going to make this a bit smaller just so we can work with the values a bit better. Let me go. No, couldn't get it. That's okay. I'll just go down here and work with it. So quarter plus half, what is that? That is the same thing as saying 3 to the power of 3/4, and multiplied to 2 3/4, and I'm dividing this by 2 cubed. So there's a bit of fractions here as you're solving for A. You can see it becomes 3 to the power of 3/4 multiplied to 2 3/4. Remember, when you're dividing, you are going to subtract the powers, so minus 3. And this now gives me 3 to the power of 3/4 multiplied to, what's it, 3 minus 12 is -9. So 2 to the power of -9 on 4. Wow, not ideal, not ideal, but that's how you would simplify A. Okay, and if you like, you can also change that negative power into a positive power as well. So you'd bring it down. You could also say, I'm just going to make this a bit smaller so I can fit that final answer. Here we go. You can also say that this is 3 to the power of 3/4 all over 2 to the power of 9/4. Okay, and then you can go back up here. Let's do B. So B, we have now x to the power of -2, y to the power of half, multiplied to x over y -3 to the power of a quarter. And I'm going to use that rule where we're multiplying all the powers with each other. So here we go. We now get x to the power of -1, y to the power of half, multiplied to x to the power of 4 over y to the power of -12. Together, collect all the x's together, so it becomes x -1 multiplied to x to the power of 4, so you add the powers together, and then times y to the power of half over y to the power of -12. Is that correct? Yes, that is correct. And so here we now know, adding the powers together, that's x to the power of 3 multiplied to, now when you're dividing, remember you subtract the powers. So this becomes y to the power of half minus -12. Double negatives is positive, so be careful there. This is x cubed times y to the power of half plus 12. And that just gives you half plus 12 is the same thing as saying 25 on 2. Okay, so knowing your fractions to begin with. So your final answer should be x cubed, y 25 on 2. There you go. So that's how you would do example 8 and example 9. You can see that example 8 really was working with some